to everyone. This is the fourth lecture of inverse trigonometric function. As in the third lecture, we have discussed 6 different graphs and also how to draw the graphs under the certain domains and conditions and other restrictions of the given inverse trigonometric functions, as in the form of 6 different questions, which are analogous to multiple angles of trigonometry, as like sine 3 theta cos 3 theta, tan 2 theta tan 3 theta, and sine 2 theta cos 2 theta type structure in terms of all tan theta. So what we do over there, as far as we concern about those all formulas, if the domain is all real number, then you can opt for substitution as x equal to tan theta. And if the domain is restricted between -1 to +1 close interval, you can opt either x equal to sine theta or cos theta. And in this way, we can redefine the inverse trigonometric functions, whatever their results are. And we can draw the graph of, as we discussed, the monotonicity and concavity of the curve according to first and second derivative of that particular function. As you know, in that 6 different question, one of the question I left over there for to do yourself. So let me recall from that, and then in this lecture we will go some more illustrations based on those inverse trigonometric functions. So let's start. So let's discuss the fourth part, which was not done in the previous. Let's start. So in the fourth part, that was the analogous to the formula tan 3 theta, that is fx equal to tan inverse 3x minus x cube upon 1 minus 3x square. So let me define this, and we'll draw the graph by evaluation of domain and range, and then later on we'll go some more on illustrations in this lecture. So let's start. If fx is equal to tan inverse 3x minus x cube upon 1 minus 3x square, so as the domain of tan inverse x, all real number, so this entire part of 3x minus x cube upon 1 minus 3x square should also all real number, and denominator shouldn't be equal to 0. So here the denominator shouldn't be equal to 0. You have to say this denominator part shouldn't be equal to 0. So let me say, that is, if 1 minus 3x square, here 1 minus 3x square is not equal to 0, so that what we call x square shouldn't be equal to that what we call 1 by 3, and this implies here that x belongs to, x means not belongs to, here you have to say x not belongs to, that is only 2 different values, minus 1 by root 3 and plus 1 by root 3. So all real number, so the domain, what we say here, domain of f will become, that is all real number, difference minus and plus, plus minus, that is 1 by root 3. This is the domain of the function. And the range of the function, range of tan inverse, you all know that it lies between minus pi by 2 to plus pi by 2, that is the same range. Now let's define the function detail. Let's see. So what we recall over here, sketch the curves. Here the domain of this one, x belongs to, that is all real number except x belongs to, not belongs to, plus minus 1 by root 3, what we have discussed here. And hence we can say y belongs to range is this, and hence we can say, we can substitute this one, x equal to tan theta, because all real number is there only except plus minus 1 by root 3. At this we find the function is as discontinuous in nature. Later on we'll discuss in detail. So let's to define the curve, you can substitute x equal to tan theta, so that it will become tan inverse tan 3 theta. So here you can say, if you check the graph of tan inverse tan 3 theta, like this, that what we say here, tan inverse tan x, the graph of tan inverse tan x is like this way. What we say, you can draw the graph of this one, that is y-axis, and here that what we call x-axis. And if we draw the graph of tan inverse tan x, then tan inverse tan of x. How to draw tan inverse tan x? Let me recall this tan inverse tan x. That is y equal to x line in the domain of minus pi by 2 to plus pi by 2. So when x belongs to minus pi by 2 to plus pi by 2 here, and once again the graph goes like this way. These parallel lines, this crossovers at x-axis pi, and at 3 pi by 2 once again not defined, as you know that tan x is not defined at odd multiples of pi by 2. So here once again you can say this is let 2 pi, and similarly you can draw more pattern of the curves here. That's okay. So let's say this is, and okay, fine, there is circle. So this is here, that is sorry, this one is pi by minus pi by 2, and this is at pi by 2. So this this is the line y equal to x, this is the line y equal to x minus pi, because if you extend this, it intersects the curve at this one pi downward. Here this will provide x minus 2 pi, here this will be y equal to pi plus x, because if you extend this line, then it intersects the curve at y-axis at pi, and later on for further, that is like this way, y equal to 2 pi plus x, and so on. But we have to restricted ourselves on this line, and this line. So this is the graph here. Let's see. So that is pi plus 3 theta if 3 theta lies less than minus pi by 2, and here 3 theta when 3 theta lies between minus pi by 2 to plus pi by 2, and minus pi plus 3 theta if 3 theta is greater than pi by 2. Here the pattern of the graph of tan inverse tan 3 theta is just like this. Now let me draw over here to make understanding in this one. So I am drawing the graph of tan inverse tan 3 theta like this type of a structure. This is x and y axis, and here this is the line y equal to x, and once again the line this will be said to be, it is passing through pi, what we have discussed over there. And this is once again, and another line that is y equal to x plus pi. So 3 theta plus pi here, and this is the graph of tan inverse tan 3 theta, and y equal to, here you can say 3 theta, and here you say y equal to minus pi plus 3 theta. So this is the graph when here this is pi by 2 to 3 pi by 2. So when it lies between pi by 2 to 3 pi by 2 means greater than pi by 2, you say it is greater than pi by 2, then you have to go for this line pi by minus pi plus 3 theta, and when 3 theta less than minus pi by 2, then you have to say pi plus 3 theta. Because why we have to 3 theta, that is the condition here, we have to go for minus pi by 2 to plus pi by 2, we have to restrict here. So this is the part of minus pi by 2. So beyond minus pi by 2 less than, this is 3 theta plus pi. So 3 theta plus pi this part, 3 theta this one, and minus pi plus 3 theta. Hence we can go ahead like this way. So in this way we can define the curve further. So let's see, substituting theta over there, that is 3 tan inverse x, and here 3 tan inverse x, instead of theta we have to say tan inverse x over there. So wherever tan inverse x, if you draw the graph of tan inverse x, then you can get the idea, that is as tan inverse x lies between minus pi by 2 to plus pi by 2. So that is 1 by root 3 corresponding to value pi by 6, and minus 1 by root 3 that's corresponding to value minus pi by 6. So tan inverse x less than minus pi by 6, it means that what we say here, let's say solve this, and we can convert over here. So x is less than minus 1 by root 3, and x lies between minus 1 by root 3 to plus 1 by root 3, and x greater than 1 by root 3, that is minus pi plus 3 tan inverse x. So this is 3 tan inverse x, pi plus 3 tan inverse x, and minus pi plus 3 tan inverse x. So the graph of this function will define by this result entire, and if you differentiate this and get the increasing and decreasing idea of the function, then you can recall how this function has a concavity upward and downward. So here you see, if we this one, let me differentiate over there. So let me differentiate here. So if we differentiate for this part, then what we call here, so let me differentiate over here, that is f dash will become here, that is differentiation of pi, that is 0, and differentiation of tan inverse x, that is 3 upon 1 plus x square, and this is under the condition when x is less than minus 1 by root 3, this is minus 1 by root 3, okay. And when x is here, that is lies between, means that is mod x is less than 1 by root 3, mod x is less than 1 by root 3, then that is the result of 3 upon 1 plus x square. Finally, what we recall over here, whatever you do here, you will get always 3 upon 1 plus x square. Means finally what we conclude, that from here each and every case for all real number, f dash is always positive. This shows that f is an increasing function. F is an increasing function. So f is increasing here. Now if you evaluate here, then what we say as f dash, f double dash. Now check for concavity. For concavity, let me write here concavity. For concavity, you have to make the double derivative, and as far in the last lecture, we have lecture 3rd, we have discussed the concavity and monotonicity of the function, how to tackle by single and double derivative. So by double derivative we can check the concavity, and if you differentiate here first part and third part, then whatever you solve, just one, this is greater than this part, means for x negative, for means in the second part also, wherever there is x negative here, you see the differentiation is negative 3 into 2x, that is 1 upon 1 plus x square whole square, because differential of 1 by x is negative 1 by x square. So this whole square, and differential of x square, that is 2x, and here that is once again, that is minus 3 into once again 2x, for that is 1 plus x square whole square. So wherever there is x is positive, here this will be negative, so concavity is downward. So for wherever the x is positive, concavity is downward, and wherever there is x is negative, concavity is upward, because negative of negative, that will become positive. So all the values from minus infinity to up to 0, negative values, for all negative values, you say concavity is upward, and here concavity is downward. So the graph pattern will go like this way. Let's see. This is the way to draw the graph here. As you can see over here, this is here at 1 by root 3, minus 1 by root 3 and plus 1 by root 3 function is discontinuous. If you see from every real number, for every real number, function has an increasing nature, increasing pattern, function is increasing, and from minus infinity to minus 1 by root 3, that is function has concavity upward, and still minus 1 by root 3 to 0, function has a concavity upward, and here you can check this here, concavity is downward. At x equal to 0, there is a change in concavity. X equal to 0 is also called point of inflection. You can say here this as point of inflection. This we can say that it is a point of inflection. Let me write over here. This x equal to 0 is here point of inflection. You can say point of inflection is a point where the concavity changes its behavior. Point of inflection. Later on we will discuss in monotonicity chapter, increasing and decreasing. So this is the point of inflection part, where concavity is changes. Here concavity is upward, and then concavity is downward, because x is positive now. Once again here there is x concavity is downward, so pattern of graph is like this way, but the function is increasing. So this is the graph here. Let's see. So this was remaining. Now let's take illustrations. Start. The value of 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is. You can pause the video and try yourself by using 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is 1 by is equal to. Options are tan inverse 31 by 17, tan inverse 4 by 3, that is 1 and 0. Let's pause it, and so now let's try to solve this here. That is If we solve 2 tan, so let's just start to solve this, how to tackle this one. Better apply 2 tan inverse x formula. That is, 2 tan, what is 2 tan inverse x? 2 tan inverse x can be written as tan inverse, that is analogous to tan 2 theta, so 2x upon 1 minus x square. So applying this formula here, we can evaluate, that is 2 tan inverse x, 2 tan inverse, that what we call 1 by 2 over here. Here we can apply this formula, and plus tan inverse 1 by 7. Then we apply tan inverse x plus tan inverse x plus y formula, that is x plus y upon 1 minus xy. So let's see over here, that is tan inverse we can write by using this above formula, that is 2 into 1 by 2 upon 1 minus 1 by 2 square, that is 4. And here that what we call 2 and 2 related, and that what we say here 1 4 by 3, right? And plus tan inverse 1 by 7. And in this way you can solve over here, that is, let make equality over here, that is the question. Here we are using formula, and that what we say tan inverse, that it will become 4 minus 1 3 by 4, that is 4 by 3 over here. And then what we say plus tan inverse 1 by 7, and solving that what we call tan inverse, that is 4 by 3, correct, that is plus 1 by 7 over here, and 1 minus 4 by 3 into 1 by 7. Solving that what we call here tan inverse 7 3 21, 21 LCM, that is related, and 7 4 28 plus 3 31, and 31 upon 7 3 21 minus 4, that is 17, correct. So 31 by 17. So hence A option is correct. Let's see the result. So what we say here, that is the result here, 2 tan inverse 1 by 2. Let me check the solutions. That is A option. Tan inverse 1 by 7, tan inverse applying 2x upon 1 minus x square, plus tan inverse 1 by 7 applying tan inverse x plus y upon 1 minus xy formula, that is 13 1 by 17. Let's take another question. So let's see, if sine inverse 1 by 5 plus cos inverse x equal to 1, then find the value of x. So here, that is sine inverse x plus cos inverse. If both of them are sine inverse or both of them are cos inverse, then it is easy to handle. So here you have to use like sine A plus B formula, and then go ahead, try yourself, and then I will give the idea, hint and solution. So pause the video and then find the solution, and then go to watch. So okay, here you can see that this sine you can take out in right side. So here what we recall that sine inverse, let's see, that is sine inverse 1 by 5, okay, and plus cos inverse x is equal to, some student can recall that it is sine inverse 1, and sine inverse 1 you all know that we can write pi by 2, and hence we can evaluate this cos inverse x. Besides, you can take this on right side, minus sine inverse, that is 1 by 5. So sine inverse 1 by 5, and hence we can say, as you know, pi by 2 minus sine inverse x, that is cos inverse x. So we can say cos inverse, that is 1 by 5, and here that is cos inverse x. Comparing, or you can say take a cos both side, you can say x equal to 1 by 5, and that is your answer. So this is a very easy problem, nothing to do over here. You can check this same pattern on the solution. So let's take one more here. May I explain this? So I can explain also. Once again, sine was 1 by 5 plus cos inverse x, applying this, and here that is same what I was dictating over there. Sine was 1 was pi by 2, and here transposing sine was 1 by 5, that is pi by 2 minus sine was 5, and that sine was theta plus cos inverse means sine was x plus cos inverse x equal to pi by 2. We are applying over here, that is cos inverse 1 by 5, and cos inverse x equal to cos inverse 1 by 5, and hence we can say x equal to 1 by 5. That is the solution. Let's check another problem. as the value of x which satisfies tan inverse x minus 1 upon x minus 2 plus tan inverse x plus 1 upon x plus 2 is equal to pi by 4 is. Here to solve the value of x equal to 0, x equal to 1, x equal to plus minus 1, x equal to plus minus 1 by root 2. I have a solution of this problem. As for this pi by 4, we can write tan inverse 1, and hence we can say that we say tan inverse x minus 1 upon x minus 2, x minus 1 upon x minus 2 is equal to 1. That we can write tan inverse 1 for that pi by 4, tan inverse 1, and transformation of tan inverse x plus 1 upon x plus 2 in right side, what we call like this way, x plus 1 upon x plus 2. If you solve this, then you will get tan inverse, that is 1 minus x plus 1 upon x plus 2, right? And then after 1 plus of 1 plus that what we call x plus 1 upon that is x plus 2 once again. So if you make it in bracket here, then what we call that is applying this result, then final it will be tan inverse denominator retaliated x plus 2, and that is x retaliated 2 minus 1 1, and hence that is 1 upon here, that is x plus x 2x and plus 3. So finally what we get here, tan inverse 1 upon 2x plus 3, and hence on comparing that, what do you say here, x minus 1 upon x minus 2 is equal to 1 upon 2x plus 3. And equating this on by making cross multiplication, you can solve this value here, that is x minus 1. This implies that what we call here, let me write x minus 1 into 2x plus 3, and hence we say that is equal to x minus 2, right? So here that is 2x square, and that is minus 3 and minus 2x and plus 3. So that is 2x square, and that what we say plus x, 2x square, let me write over here 2x square plus x, 2x square plus x, and that is plus minus 3, yes, 2x square plus x minus 3 and x minus 2. So right over here 2x square plus x minus 3, and here what we say x minus 2. So on solving this, x retaliated over here, so that is retaliating x both side, this x retaliated here, okay, that is finally what we call here 2x square, and that is minus 3 and plus 2 equal to 0. So finally what we get, 2x square minus 1 0, and that is x belongs to plus minus 1 by root 2, that is 1 minus 1 by root 2, and one can say also the result will be plus 1 by root 2. Both are the feasible results. So this is your final answer. So that is this one, x equal to plus minus 1 by root 2. Let's see the solution. Yes, that is for pi by 4 we have written tan inverse 1, and here you can say the solution like this way. So let me draw a line to make a margin over here to avoid such confusion, okay, from here, and this is one part, and this is another part, that we say tan inverse x minus 1 upon x minus 2, tan inverse 1 minus x plus 1 minus tan inverse x plus 1 upon x plus 2, and hence we get the result x equal to plus minus 1 by root 2. That is the same here. You can also solve. So let's see another question. So the new illustration is that still applying the tan inverse x plus tan inverse y formula type structure. The value of x satisfies tan inverse 2x plus tan inverse 3x equal to pi by 4. You can pause the video and get the solution by yourself, try yourself, and then you come to the video and watch it. So let's see the solution. Tan inverse x plus tan inverse y, here applying 2x plus 3x upon 1 minus x into y, that is tan inverse 1 for pi by 4 we can write. As you know, this is here, if you multiplying 2x and 3x square, that is 6x square less than 1, no problem, you can simply add it, 5x upon 1 minus 6x square 1, and here that what we solve, after solving that we say this is the condition of if 6x square is less than 1, you know, 6x square is less than 1, the condition should be there. Then only we can apply simply the formula tan inverse x plus 1. So solving this, we say x, that what we call x square is less than 6. So here by using wavy curve method, you can see that is the result will be x equal to here on this quadratic question. If you solve this, there are two results, minus 1 and 1 by 6, but x should be under this condition minus 1 by root 6. So x equal to 1 by 6 is the feasible solution. So no need to detail explanation here. That is, the result is perhaps x equal to 1 by root 6. Next question. The value of x which satisfies 2 tan inverse cos x is equal to tan inverse 2 cosec x is x equal to n pi, x equal to pi by 3 plus n pi, x equal to pi by 4 plus n pi, and none of these. You can once again pause it and try yourself, and then you have to use your trigonometrical equation type concept, or general trigonometric equation. So let's have a solution. Here 2 tan inverse cos x, we are applying formula 2 tan inverse x, that is, that what we say here. If we say 2 tan inverse x formula, you should make a memorize by the formula 2 tan inverse. Let me write t over here to avoid such confusion. So we can say tan inverse, that is 2t, means that is formula of theta type structure. So you have to say like this way, that is, let me write once again by using this another color. So 2 tan inverse, that is t, we can write tan inverse 2t upon 1 minus t square. This formula you can use over here. So tan inverse 2 cos x upon 1 minus cos square x, and here as it is tan inverse 2 cosec x, and tan inverse something is tan inverse, take a tan both side. If you take tan here in both side like this way, here also you can take tan both side, right? Then we can say directly tan of tan inverse t, tan of tan inverse y is equal to, you can say y over here, that we are using over here. So that is 2 cos x upon sin square x, 1 minus cos square x, we can say sin square x, and 2 cosec x, and then solve it by as a equation by multiplying over here. That is cosec, you can write for this one of the sign related, and hence we can say you can't retaliate here sin x. If you are writing the one sin x retaliating, then you will miss the solution. So that's better, just take it common over here, left side. So cos x into sin x, that we can say 1 upon sin x and then cross multiply, and then is equal to sin square x, and cos x minus sin x bracket into sin x equal to 0, and hence we can say cos x equal to sin x and tan x equal to 1, and this provides the solution because x shouldn't be equal to sin x shouldn't be equal to 0. So that's we say x equal to pi by 4 plus n pi. This is your solution, and that's your answer. So C option is correct. Fine. So let's see another question. Let's say the value of x for which tan inverse under root x square plus x plus sin inverse under root of x square plus x plus 1 is equal to pi by 2. Pause it and try yourself first, and then come to the video. So let's start. Here B option is there. The reason is that the equation will well hold because under root of fx. Here we have to use this result as a let me see, as that is under root of fx. For under root of fx, we have to make fx should be greater or equal to 0. So here if you see left side, then here that is the under root part. Here in under root part we have to make this both greater or equal to 0 here, and if you see over here, then here this part also you have to make greater or equal to 0. So this part is also greater or equal to 0, you say, and here that is also, as this part is here in this, as this is in sine inverse, so we have to make it's less than 1 also, because sine inverse x lies between, domain of sine inverse lies between -1 to +1. But due to this, here you have to make greater or equal to 0. So this is all the result. Here you have to make greater or equal to, less or equal to 1, and that is greater or equal to 0. So solving these two inequalities, what we say here, x is equal to, that it means x square plus x is greater or equal to 0. Here we find x square plus x is less or equal to 0. The only solution here, and means you have to make this intersection, and means here you have to make intersection. So in intersection, only the condition, that is x square plus x equal to 0, is common in both. So x belongs to 0 and -1. So that is the only solution. X belongs to 0 and -1. That is the only two solution. So there are the two solution here, and hence that is the result, you know. So that is your final answer. B option correct. Let's take another question. X equal to cosec of tan inverse cos of cot inverse sec of sin inverse A, and y equal to sec of cot inverse sin of tan inverse cosec of cosec inverse A. Find the relation between x and y. What is the relation between x and y? Let's see. So one by one you have to solve x and y, and then later on we will get the relation. Let's see. You can pause this and you can try also yourself by substituting sine inverse something and then come for sec, because all the inverse trigonometric are angle, nothing else. Well, let's see the solution. To solve x, we like this way, and sine inverse A can be converted by in sec like this. As you know, I can give the clue over here. If you check sine inverse A as theta here, if you say sine inverse A as theta, so that it means sine theta you will get as A. So if you get sine theta as A and you make the triangle here, then that is A upon 1, and here in this way you can say under root, that is 1 minus A square, means the square of the hypotenuse minus that is altitude, square of altitude. By applying Gogol theorem, you say also Pythagoras theorem. So here that is sec of theta. So here that is the particular angle theta for which sine theta was A, that was altitude upon hypotenuse, and here for sec theta you can write 1 upon under root 1 minus A square. So we can say this theta as, so we can say from this triangle, that is sec theta, that is you say under root of 1 upon hypotenuse upon base, that is 1 minus A square, and hence we say theta equal to sec inverse this. That what we are writing over here. Theta is sec inverse this. So we write sec inverse this. Now sec of sec inverse, that is the same. Sec of sec inverse, t of t inverse of theta. For any trigonometric, you can use this directly, that is alpha. If you write here alpha, then any trigonometric you can write here t of t inverse alpha, that is simply alpha you can write. So that what we have written, sec of sec inverse alpha, that is alpha. And now once again cos of cot inverse. Now this cot inverse you have to convert in cos inverse, so that we can use cos of cos inverse. So same process, as you know, cot inverse is 1 upon under root 1 minus A square. So once again you can make the table here, or triangle, right angle triangle. So cot inverse, that is 1 upon under root of, here you have to write 1 upon under root of 1 minus A square as this base upon altitude, and with the help of this you can find the hypotenuse over here, that is 1 plus 1 minus A square, that is 2 minus A square. So root of 2 minus A square, and cos inverse that is here for that particular angle, let's say beta. So that is beta is equal to cos beta, that what we call 1 upon under root of 2 minus A square, and hence we say cos inverse 1 upon 2 under root 2 minus A square. Now you can apply a cos of cos inverse 1 upon under root 2 minus A square, so that simply this result will be 1 upon under root 1 minus 2 minus A square, and that will be tan inverse 1 upon under root 2 minus A square, so that it will become cosec of tan inverse. So simply you can write 1 upon under root of, that is 2 minus A square. And then once again for this tan inverse you can convert into terms of cosec. So let's see how to tackle this. So we say cosec of this one, and we can say tan inverse this in terms of cosec. That is the same process here. You can say cot inverse 1 upon under root 1 minus a square, that is tan inverse. So that it means cot inverse, we have converted in cot inverse, and here cosec of tan inverse, so cosec inverse under root 3 minus a square, and hence we say this will become x belongs to x equal to under root of 3 minus a square. Now go for check for y also. Similarly, y, same procedure, cos inverse a convert in cosec. So cos inverse a is equal to cosec inverse 1 upon under root 1 minus a square, and hence we say cosec of cosec inverse, so that it will be same result as t inverse of theta, that is theta. So alpha, what is that alpha, that is, so means on inverse trigonometric function in f inverse of fx, if any is there, f of f inverse x, and directly you can say that is fx x. So f of f inverse x, you say here like whatever I told over there, f of f inverse x, especially in trigonometry, that is here we can say x. But if f inverse of fx, then in trigonometry you can't say x directly, as it is a periodic function. So in other words, the function is not periodic over there, as no inverse trigonometric functions are periodic. So we check out like this way: sine of tan inverse 1 upon under root 1 minus a square, and tan inverse can be converted in sine inverse 1 upon under root 2 minus a square in the similar process, and sine of sine inverse, that is the same, and here, and that is cot inverse of that angle, and then go ahead the same pattern and sec of cot inverse this, and hence we say x equal to y under root 3 minus a square, and y also equal to 3 minus under root 3 minus a square. So we find that is x equal to y. Y was also under root 3 minus a square, and x was also 3 under root 3 minus a square. So we say here it's printing x equal to y, that is not under root 3 minus a square, right, as y was also under root 3 minus a square. And if you see that x was also under root 3 minus a square, x we have also derived under root 3 minus a square. So x and y, both of them are same. So in this way you will get this result. So let's see the solution. Let's see, the question was there, so D option was correct. Yes, the option was D, and hence we say D option is correct result. So x, first of all we have evaluated x by using triangles and making the angles over there, and then after evaluating x, that was, if you see, that was x, that was, and y also, that is same, under root 3 minus a square. Next, check another problem. Let's say, so illustration concept, illustrating the concepts here, that is 3 illustrations are there. One is cos inverse x by a plus cos inverse y by b is equal to alpha. Then prove that x square by a square minus 2xy upon ab cos alpha plus y square by b square is equal to sine square alpha. Second question is, if cos inverse x plus cos inverse y plus cos inverse z is equal to pi, then what we say here, then we have to prove that x square plus y square plus z square plus 2xyz equal to 1, right? So let's see here. Anyhow, and if sine inverse x plus sine inverse y plus sine inverse z equal to pi, then prove that x under root 1 minus x square plus y under root 1 minus y square plus z under root 1 minus z square is equal to 2xyz, and another part, that is x to the power 4 plus y to the power 4 plus z to the power 4 plus 4x square y square z square is equal to 2 times of x square y square plus y square z square plus z square x square. Let's solve. Pause it and try yourself. So first one is very well known and renowned question. Let's see the solution. First part, as cos inverse x plus x by a plus cos inverse y by b is equal to alpha, then you have to prove this. So here what we will do, think about, as you know, applying the formula cos inverse x plus cos inverse y, cos inverse x plus cos inverse y is cos inverse x y under root 1 minus x square plus under root 1 minus y square. So for x, that is x by a, and y, that is y by a here. So y by b here. You can check this. Some error is there. So that is, let me write, that is y by b is here. So let me zoom this portion, and here that is y by b is, so this part is b perhaps, yes, y by b. So x by a, y by b, and under root 1 minus y square by a square. Okay, fine. So that is x by a, and here that is y by b. Now apply cos inverse xy under root 1 minus x square by a square, and under root 1 minus y square by b square. And then simply of this cos, take a cos both side, and then becomes, this result becomes cos alpha, right? And here it will become cos alpha as per. So if you see here, if we transpose this cos alpha from here, this cos alpha from right to left side, so we find here that is x y upon ab and minus cos alpha, that is equal to under root 1 minus x square by a square, and here that is under root 1 minus y square by b square, this part, and under root 1 minus y square by b square, that is, we say, squaring both side, that you get the result